Hello, everybody. Let's continue with another problem going over Snell's law. So this problem reads, a ray of light is traveling through air, and that ray of light right here is represented by this arrow right here pointing into the glass jar. When it hits a glass of water n equal to 1.33 at an angle of 75 degrees relative to the normal, find the angle of refraction in the water. So to start with, we have this light coming in right here, right? And as this light comes in, it hits a glass, so it changes its angle. For here, what's really confusing is this dotted line right here is our normal line, right? And so we don't want to measure this angle right here. We actually want to use this angle right here to our normal. And when we see it come out, we actually want to measure this angle right here going away from the piece. So we start out with an n of 1.00 and then we get an n of 1.33. And so what we'll expect is for that angle to be a little bit more shallow, right? So we come in with 75 degrees relative to the normal, and we come out with a bit of a shallower angle. And it's up to us to actually figure out what that angle is. So we'll start out by looking at the equation for Snell's law. Right? We know our air n, we know our water n, right? So we can just plug in these numbers. We know sine of 1 of theta is going to be 75 degrees. And so we get 1 sine 75 equals 1.33 sine of theta 2, right? And then so we need to get this sine by itself. And there's two things that are in the way there. There's the 1.33 multiplied by the sine, and then there's the actual sine by itself. And so to start, we'll divide by 1.33. Right? Because then we'll get this sine of theta 2 is equal to 1 times sine of 75 over 1.33. And then what we need to do, and goes back, so this is a little complicated, right? Is we need to take the inverse sine of the right side, right? And so I'm just going to take out the pen right here. If we take the inverse sine of both sides, we're taking the sine minus 1 of both sides. The inverse sine of sine will just give us that theta. And so we have theta 2 is equal to sine, an inverse sine of 1 times sine of 75 over 1.33. And hopefully you got that when you were working on this problem earlier. So that's how you solve this problem. Remember, this is going to be your normal line. Our angle is always going to be measured off of that, right? When we're talking about this angle right here, that's going to be our theta 2. It's not going to be this angle. That wouldn't be correct. Best of luck, y'all. I'll see you in the next video.